Alrighty, so to start off our Unit 9, Lesson 1 lesson about translations, first thing we want to just do is review some transformations that I think you guys have learned in the past. We're just going to kind of review, and if you don't know these ones, that's okay. We're just going to look at maybe what would a translation look like versus a reflection versus a rotation. So the first thing we're looking at is we've got triangle A, and we are trying to figure out which of the three other triangles, B, C, or D, match with the following transformation. So the first one is a translation. Now what translation means is it's a slide. So we are sliding down and over. So the triangle that matches as a translation is triangle B. Next one is we're looking for a reflection. Now reflection is the one that like flips, like you're thinking about in a mirror. And in that case, that one would be triangle D. Last but not least, rotation is turning the shape or turning this triangle. And so in this picture, it would be triangle C. You can see that it looks like it was shifted and then also rotated. Now talking about transformations just in general, what they are is they're a move or a change to a figure in which we call an image. So the original shape. And there are different types of transformations. What we're going to talk about in class is translations, what we're learning today. There's also dilations, rotations, and reflections, and we'll kind of cover each of those every single day. We'll do a new one. So the first one we're looking at today is translations, and that is the transformation that moves every single point of the figure the exact same distance and the exact same direction. So same distance and same direction. For example, in this image that I have below, we have triangle ABC, and we can see that it went up and then to the left. Every single point went up and to the left. Now what these transformations, or all transformations, have is a specific rule. And what that rule does is it guides or it shows how each point was shifted. And this is used for all types. For translations though specifically, you can denote the horizontal shift with the x coordinate and the vertical shift with the y coordinate. And last but not least, kind of in our vocab section of our notes today, is image versus pre-image. So what the pre-image is the original shape or the original figure. And the image is what the shape is after it's undergone a transformation. So after a translation or after a rotation, that's what the image is. And we have some special notation. What that notation looks like, it's the letter of the point with a apostrophe. So it's called A prime, B prime, and C prime is how we would speak it. And we can see off to the side here, those points. It was A, now it's A prime, B, B prime, C, and C prime. Alrighty, with all of that vocab, let's go ahead and put it to the test here. So what we have is the vertices of J, K, L, M. And we know that J is -1, 6, K is 2, 5, L is 2, 2, and M is -1, 1. We want to graph the pre-image, this original JKLM, and then also graph the image of JKLM after it was translated 3 units left and 1 unit down. Let's go ahead and start by just putting on those original points. So we have J, K, L, and M. I'm going to go ahead and put these on by going -1 up 6. This is my point J. Going to K, I'm going over 2, up 5, over 2, up 5. L is 2, 2, and M is -1, 1. While we are kind of getting in the swing of this new unit, it is really helpful to graph your points as well as label them as you go, so you can see that pre-image versus image. And next thing that this is telling us is we're going 3 units left and 1 unit down. Now there's 2 ways that we could figure out what this shape is. Now I'm assuming the easiest way, and the thing that we'll probably get to be used to, is just counting from your point. But eventually when we do rotations and reflections, it is easier to use the rule method, which we'll do on the next slide. So for this one, we'll just do the classic count and then place the new point. So this one is saying the image JKLM is going 3 units left and 1 unit down. So from every single point that we have, if I zoom in here, we're going to count to the left, 1, 2, 3, and down 1. And this is your new point, or J prime. I'm going to do M now. We're going 1, 2, 3, down 1. This is M prime. 1, 2, 3, down 1 is K prime. 1, 2, 3, down 1 is L prime. Alrighty, with these all graphed, we can connect them, and our shapes overlap a little, which is okay. But we can now see that new image, or the pre-image and post-image of this translation of 3 left, 1 down. Now what we'll also be working with is the rule. Again, that rule is telling us what is happening to the shape, what is that transformation. And so in order to figure out a rule, there's kind of two ways we could do it. What I always like to start by doing is writing down what is the pre-image points and what are the image points, and we can compare their coordinates. This is a triangle, so we've got 3 points. So I'm going to write down A, B, and C. And let's write down what those points are. A is at the point 1, negative 1. B is over 1, 2, 3, 4, up 1. And C is over then 1, 2, 3, 4, 5, down 1. Now the image is now after the shift, so it should be all of our prime points. And now we can go ahead and figure out what these ones are. Looking at A prime, that's the left 1, 2, 3, 4. So negative 4 up 1. B prime is negative 1 up 1, 2, 3. And C prime is 0, 1. Here's what we can do. Now your rule is going to have special notation. It's always going to be a point, but it's kind of a longer point because we are going to put in what's happening or what the rule is while we're working with this one. So I'm just going to kind of map it out, looking like this point, leaving some room for where we're going to put our rules here. And then off to the side, let's kind of do some writing of what's happening. So when we're thinking about your horizontal shift, that's always left to right. So we are looking at how your x's are changing. So how are we going from 1 to negative 4? What is happening from 1 to get to negative 4? Well, when we're thinking about 1 to negative 4, I think it's minus 5, right? 1 minus 5 is negative 4. Let's test that out for the rest. How do we get from 4 to negative 1? 4 minus 5 is negative 1. And last but not least, 5 minus 5 gets us to 0. Excuse me. So what this tells us is minus 5 is that transformation. That's what's happening. So where we have your rule, we can say that all of the x's we're subtracting 5 from. Now doing the same thing with our y's here, let's look at the y's and see how those change. So we are going from negative 1 and we're somehow getting to 1, negative 1 plus 2. Excuse me. Let's double check if that plus 2 is the same for everything. So let's see if this is 1 plus 2. Does that give us 3? It does. Negative 1 plus 2 gives us 1. Cool. So that all checks out too. So your rule here for your y's is that you're adding 2 to them. So we have just figured out the rule. Now I'm sure you're like, hey, Miss She, can't we just count it? You could. We could. I just want you to see how that rule is formed. But if you're given the image, you can also count it. So what we can do is go on our graph and say, hey, is it true that maybe from B to B prime, we're going up 1, 2, or plus 2? And then we're going to the left 1, 2, 3, 4, 5, or negative 5. And you can verify that for all of your points as well. Alrighty, next we've got this one. We have graphing the quadrilateral ABCD with these vertices A, B, C, and D. We want to then find the image, so after that transformation of plus 2, negative 4. Cool. Okay, looking at this one, let's start by putting on the original quadrilateral A, B, C, D. So A is at negative 1 up 2. B is negative 1 up 5, C is over 4 up 6, and D is over 4 up 2. Sweet. Okay, we have your quadrilateral, your 4-sided shape here. And what we want to do now is find the image of the vertex after the translation. Cool. So what it might be helpful to do again is it wants us to identify what the vertices are after the translation and then actually graph it. So this is one where it might be helpful to write it down as we go. I'm going to write down A, B, C, and D and just write down our points quick. So it's negative 1, 2 for A, negative 1, 5 for B, 4, 6 for C, and 4, 2 for D. And this is the pre-image. What we want to now find is what is the image if we are undergoing a translation. So I'm going to write down all of our primes, and then let's actually undergo that transformation, and we are given the rule this time. So this time it's saying, hey, what if you add 2 to your x's and subtract 4 from your y's? Let's go ahead and do that one. So we're going to do -1 plus 2. That would be 1. Oops, let me get the right pen here. 1. Perfect. -1 plus 2 is 1. 4 plus 2 is 6. And 4 plus 2 is 6. Cool. So I did the plus 2 for all of my x's. Now for all of our y's, we're going to subtract 4. So 2 minus 4 is -2. 5 minus 4 is 1. 6 minus 4 is 2. And 2 minus 4 is -2. With that, we can graph our new points here. So our A prime is 1 down 2. This is A prime. B prime is 1, 1. B prime. C is over 6 up 2. And D prime is 6, -2. And we can connect our points here. And we can confirm that translation. Another vocab word to throw into the mix is isometry, and it's where a transformation occurs and the length and angle measurements are preserved. They're the exact same. So I pulled 2 examples from here. This is an example of an isometric translation because, as we see, all of the side lengths are the same: 4, 4, 3, 3, and 5, 5. Whereas over here, this one is not, because our side lengths change. This was 2, and now this is 1, 2, 3, 4. It was 1, now it's 1, 2. So this one is not the isometric transformation or translation. Now what we want to do using this new knowledge is to write a rule for this translation and then verify that is in fact an isometry. So let's go ahead and write down your rule. So I'm going to go ahead and write our rule down. To write down our rule, again, that's going to be a coordinate. We just want to leave some room to figure out what's happening here. Now I'm just going to look at the points. Looking at these ones, it looks like we are going from A to A prime. We're going up 1, and we're going 1, 2, 3, 4 to the left, or -4. So our rule would be x's -4 and the y's +1. Now with the rule, we want to verify that it's an isometry. And again, with isometry, we want to make sure that the sides are all the same and the angles are all the same. So our very first thing is going to be, we need to verify that the sides are all congruent. That's going to be our very first step. So let's go ahead and let's try to determine that our sides are all the same. I'm going to start with maybe AC, this side. And let's figure out if this is the same. From A to C in our original triangle, it's 1, 2. And in A prime and C prime in the new triangle, that one is 1, 2 as well. Cool. So we know those sides are the same. I'm also seeing that C to B lies nicely on our coordinate plane here, and we could figure out what those ones are. So let's do C to B next. Going from C to B, it's 1, 2, 3. And C prime to B prime, let's figure out what that distance is, because it's also on the coordinate plane nicely. This one is 1, 2, 3 as well. They're both 3. That means they are preserving that length. Now what we don't necessarily have is A to B or A prime to B prime's distance. Because that's where we're at that diagonal. And there's kind of 2 ways you could go about it. You could go ahead and do the distance formula if you so choose. I am noticing, though, that we've got a right triangle happening. So what I'm going to do is draw out our right triangle and label it A, B, and C. I know it's a right triangle, right? Because it's landing on our coordinate plane exactly with a perpendicular slope. We've got that straight up and down undefined slope. And the left to right 0 slope. We know that those ones are perpendicular. What we can do then is label them. So from A to C, we knew this was 2. from C to B, this was 3. And our goal is to find what A to B is. So I'm going to label that one X. Now that we've got your triangle drawn out, we can go ahead and do the Pythagorean theorem. And we can do 2 squared plus 3 squared is equal to x squared. Or 4 plus 9 is equal to x squared. Or 13 equals x squared. When we square root, this gives us just about 3.6. So from A to B, it's 3.6. And you guys, to A prime to B prime is also 3.6 because they have that same dimension. Cool, so we have verified that all of the sides are congruent. Now your second part is to verify that all the angles are congruent too, that nothing shifted during this transformation. First thing we can write is, well, hey, we know that angle C is 90 degrees, and we know that C prime is 90 degrees too. So those ones are taken care of. Now what we need to do is we need to figure out angle A, and we need to figure out angle B. What we can go ahead and do is look at some of our memories with some trig here. So I'm going to rewrite out SOHCAHTOA for us. And what we can do is some trigonometry to find either A or B, honestly. Maybe let's find A. Let's go ahead and figure out what A is. So I'm going to put maybe a y here for a variable. And let's go ahead and label this triangle in respect to angle A. Now looking at A, I'm going to circle it. We've got the opposite side, our hypotenuse, and our adjacent. We want angle A. We honestly can use any of the sides, but I think let's use the whole numbers, not the decimals. So let's do O and A. O and A is tangent. So we're going to do tangent of angle A is equal to O over A, or 3 over 2. Now, as a reminder, whenever we are solving for an angle, we always have to use the inverse trig function. And we do that because right now that variable is kind of trapped in that trig function. So these are going to cancel each other out and just leave us with A is equal to that inverse tangent of 3 over 2. This becomes just a calculator thing. So we're going to do inverse tangent of 3 over 2, which gave me 56.3. If this is 56.3, so is your other A prime. So these are both 56.3. That checks it off. I'm sure you can assume that B's are the same. Just for fun, let's figure out what those actually are. Excuse me. And we can use either trig again, or I'm assuming you guys will probably want to use the triangle sum theorem, which says all of the angles should add up to 180 degrees. So we can do 180 minus that 90 we know, minus your 56.3 we know, and that will give you what your missing angle B is. So let's plug this into the calculator quick. When I put that in, that gives me 33.7. So that tells us that both of these angles are 33.7. And furthermore, this is an isometry because all of the sides and angles are the same from the pre-image to the image. All right, last one, and then we'll wrap it up. Looking at this one, this is the image and pre-image of this red and blue triangle, and what we want to do is find the values of A, B, and C. And what we just kind of went through was every translation is an isometry. And as a reminder, isometry means that all of the values are preserved. So all of your sides and angles are congruent or preserved from pre to post image. And so what that tells us is we can find the corresponding lengths and angle measures, and we can set them equal to solve. So looking at our triangles here, let's go through and solve some. Maybe we start with angle A we want to find. Now looking at angle A, there isn't another number or variable in here that's really going to help us. But what we do know is if that was angle A, this is angle A as well. So what we can do is use that triangle sum theorem that we were just talking about, and we can help ourselves out by saying that all of those angles should add up to 180 degrees. Or in other words, 180 is equal to 90 plus 55 plus A. This just becomes some solving here where we want to subtract over the 90 and the 55. So we find that A is equal to 35. A is 35, and this A is also 35. They're going to be the same. Woo! Okay, we got our angle. Let's go ahead and keep solving. Looking at this one, maybe we find B next. B and B are corresponding with these sides. So we can say that B plus 6 is equal to its corresponding side, which is 20. We can subtract this 6 off and find that B is equal to 20 minus 6, or 14. Last but not least, I am noticing that we have C defined. Whoa, that's not my highlighter. Let's try again. There we go. C corresponds with this side, 14. So we can do is say that 4C minus 6 is equal to 14. Then this just becomes an algebra problem where we want to add over your 6 to get 20. Divide by 4 to find that C is 5. Alrighty, that is your first lesson of Unit 9, all about translations. There is a homework assignment for you guys to try. Tomorrow when I'm back, you can ask any questions that you have, but for now, get started on Unit 9, Lesson 1 homework.